Okay, good morning once again. Today, guys, we're going to discuss another type of regression. It's called binary logistic regression. So let's just change this binary, okay? Because there's also this multinomial logistic regression. Okay, now how does binary logistic regression differ from the multiple linear regression that we have discussed so far? The main difference is that in the multiple linear regression, your dependent variable or your response variable is a continuous variable. Okay. On the other hand, for a binary logistic regression, your dependent variable is a categorical variable. It's a factor variable. So that's the difference. And it's not proper to use a regular linear model, regular regression for a binary logistic regression. There will be errors, guys, if we use that. Okay, so there's a special way to regress your dependent variable, which is a factor containing two levels, true or false, yes or no, male or female. So dalawang levels niya, no? If there are two levels, then we make use of what we call binary logistic regression. And today we're going to explain sorry, how, excuse me. Okay, how we make use of, how we run a binary logistic regression. Okay, and then we're going to use this data, okay, this binary.csv, which I shared with you before. So why don't we download that? Okay, and you can use the import data set. So let's use the base R. Okay, and it's under my FINTSAR logistic regression. So this is the file, guys, binary.csv. So let's open this. Okay, so the name of the file is binary. So let's just make this my data. We can change the name, my data, because here we're using the my data as the name. Make sure that there's a heading. Okay. All right. So we can now import this. Import. So we now have our data, my data. Okay, I named it my data. Okay, if you take a look at our data, there are 400 observations and there are 4 variables. You have here admit, GRE, this is the graduate, I forgot the name, graduate. It's an examination that's given out to candidates for those applying for graduate school. Okay, so in the US, this is very popular, the GRE. And then also the GPA of the student when he graduated from college. And then the rank. The rank of the school, so they categorize the school, one being the best type of school, okay, high Ivy League schools. Rank 2 will be those second best. Third will be medium, and then maybe fourth, the lowest rank among the schools. So this college, this university ranked the schools and gave it, depending on where the student came from, and gave it a rank of 1, 2, 3, 4. So let's see if this rank will affect the decision of the school to admit or not to admit the student, the applicant. So this is this data we have here for student number 1. This student was not admitted to the university. The GRE score was 380 and the GPA was 3.61, and that student came from a 3rd-tier school. Student number 2 was admitted, so that's 1. Okay, so 0 and 1 here is binary. So there are only 2 possible values for admit, either 0, which means the student was rejected, or 1, the student was accepted. And then here we have the GRE rating, and then the GPA of the student, and also the rank of the school where the student came from. So there are 400 observations here. And we'd like to come up with a model that will predict whether the student, any student with a GRE score, GPA score, and the rank of the school where he or she came from, will be admitted or not admitted. Okay, so this is an example of a binary logistic regression. And then after this, guys, in fact, before we go to multinomial regression, I'm going to introduce another method, which is what we call decision tree. Okay, so we're now interspersing econometrics using regression and also a machine learning. Okay, so in decision tree, it's machine learning, and we'll try to compare how machine learning fares in comparison with a binomial logistic regression. Okay. All right. So let's go back to our model. Let's take a look at the structure of our data. So the structure of our data is, you can see here, the admit is an integer, GRE is integer, GPA is numeric, and rank is integer. Now we have to change, admit is not really an integer, guys. So we have to change this into a factor. Okay, this will be treated as a factor. It's a classifier, whether the student was admitted or not admitted. And then also rank will be used as a classifier and not an integer. Okay, so we convert that, guys. My data, admit, so this is the variable. We're using the same variable. And then we're changing the my data from the original my data, admit, we're going to change it into a factor. And also the my data variable rank, we're going to change it also as factor. So let's run this two. Run this two. Okay, so we have now converted admit and rank as a factor. And then let's take a look again at the structure of the my data. Okay, and we now see that admit is now a factor and rank is now a factor. Okay, let me pause for a while. Any questions, guys, so far?
None, sir.
So, okay, good. Paki-chat naman, guys, yung iba kung okay tayo so far. Good. Thank you so much. All right. Okay. All right. So, oops. Okay, then let's now see, guys, using a two-way cross-tabulation. Let's see. Let's try to plot how many were yung admitted at saka yung rank ng school nila. No? So let's try to see how many of those admitted came from a rank 1 school, a rank 2 school, etc. So let's run this using the function crosstab, xtab. Okay, so you can see here that admit has 0 or 1. So 0 is not accepted, 1 is accepted. And then from the rank 1 school, okay, we can see here that in rank 1 school, of the 61 applicants, 33 were accepted. So more than 50% were accepted for those coming from rank 1 school. For those coming from rank 2 school, you see that almost just 1/3. Okay, 54 lang out of 151 were accepted. Okay, so bumaba lalo sa pag rank 3 yung school, only 28 out of 93. And then for rank 4, only 12 out of 55. So we can see that indeed, it seems as if the rank has a say. No? It has a say in determining whether a student will be accepted or not based on the percentage. Okay, is this clear, guys, on cross-tabulation at all? So we just used the function crosstab and then tilde, admit plus the rank, and then from the data is equal to my data. All right, so I think this is self-explanatory. We can, of course, guys, get a percentage of that, but let's do that later. Okay, let's just continue first. Okay.
Oh, sir.
Yes.
I have a question.
Sure.
Because for my in line 17 for
line 17 okay.
Yes, sir. Reading the CSV file, the path. When I try to run it, it says there's an error, sir.
Okay, sige. Tingnan natin. Can you? Okay, let me stop sharing. How can you share? I'll make you co-host.
Yes, sir.
Okay, can you share your screen, please?
Okay. Here, sir. Can you see the screen, sir?
Yes, okay. So let's see.
There, it gives me this errors.
Can you max in the list? Baka sa view ko.
Oh, sorry, sir.
Let me see. Kasi hindi ko makita masyado. Side by side. Wait. Standard yan. Okay, I made it standard. All right. So read.csv header is equal to true. Okay. Did you just copy the file location?
Yes, sir.
Kasi di ba ayaw ni R ng backward slash?
Oh, yes, sir.
Diba? Kindly change it into forward slash, please.
Oh, yes, sir.
Sige, let's try it first. How? Okay, good.
Do I select binary? So it brings up a small window where I'm supposed to select the file.
Sige, i-ano na natin. And then if you my data, insert another line there. Okay, view my data. Kasi andyan ay my data mo is already available there. Okay, sige, run mo siya.
Sorry.
Error in could not find function. Capital V, capital V.
I see. Oh, there.
Okay, there you go. Okay, so okay na, no?
Thank you, sir.
So convert mo na convert mo na yung data mo into factor, ha?
Yes, sir. I'll run the chunks. Thank you, sir.
Thank you. Thank you. Okay, sige, share ulit ako, no? Okay, thank you for those questions, guys. Thank you, Pao, for that question. Okay, I appreciate really those questions.
Yes, sir. Thank you.
Okay. All right. So let's continue. Any more questions, guys? Okay. So I don't think I discussed with you partitioning data before, no? Not yet, no? Yes, please. Yes or no?
No, sir.
No. Okay, good, good. So this will be the first time that we're doing this. Okay, now usually when we do machine learning, okay, machine learning is, there are two types, supervised and unsupervised. Actually, tatlo, reinforcement learning pa, no? But we'll get to that later. No, not later, but maybe next session. When we compare a machine learning tool like decision tree with a regression model like this, it's interesting, guys. So that will give you a flavor of machine learning tools. Okay, so what we do is we do not use everything. The 400 observations we have for my data. Okay, if I click my data, di ba 400 observations siya? What we do is to you partition the data, use a certain part for modeling, and then use the other part for testing. Because we would like to see if our model will work even if the model has not seen as SEEN a particular data. So in this activity, we're going to partition our data. Okay, we're going to call one data set as trained data and the other one as test data. So we're going to model a binary logistic regression using trained data, and then we're going to use the test data and see if our model works with that test data. Okay, so how do we partition data? So this is one of the ways. There are other ways, but this is one of the easiest ways to partition our data. So what will happen is that number one, we're going to set a seed so that the choice of the data will be the same for all of us. So let's set that seed. Let's run this first. Set that seed 1, 2, 3, 4. Okay, did I discuss set that seed before? Okay.
Yes,
Thank you. Okay, thank you. Because sometimes, guys, with 3 different classes on using R, guys, I tend to forget if I discuss a particular code with a particular section. So the set that seed, guys, is used for randomization. What will happen is that since we're going to use a random random function sample, all of us will get the same, same random sample. Okay, so here we're creating an object called index. This is a short for index. Okay, of course, you can give it a different name. And then we're going to use the sample function. Okay, sample, we're going to sample our data into two. Okay, in other words, we're going to split it into two. Okay, so how many rows are we going to use in splitting it? We're going to use n row my data. Okay, what's n row my data? N row, let me write that, my data gives us, okay, the number of rows, okay? Number of rows of my data. So we have, my data has 400 observations, and we're going to split those 400 rows. Now take note, replace is equal to true. So this is a type of testing where, imagine guys, you have a bowl, and then you're getting marbles out of that. When you get one and you record the color, you put it back. So that's what you mean by replacement is equal to true. And then the probability is 0.8 and 0.2. So the first sample will be 80% of the data, and the other one will be 20% of the data. Okay, so usually the range can be from 60-40, 70-30, 80-20. It really depends on the size of our data. If it's 400, it's not really that big, so we're giving a bigger ratio to the trained data. If it's a big data, sometimes you can use 60-40, okay, or maybe 65-35 if the data is a big. So this one for 400, that's not really a big data. So we're just going to use 80% of that for our training data and 20% of that for our testing data. Okay, so let's run this. Okay, so now we have now ind. If you take a look, this guys at this, you know, take a look at ind. No? So let's first see what ind is. I'm going to type it here, ind. Okay. Okay, maybe view, better view, and then ind. So let's see what ind is there. Okay, so take note, guys, that you have here numbers 1 and number 2. So what happened was R partitioned our data into 1 and 2. Now, all of this, those that are number 1 will belong to group 1, and those that are number 2 will belong to group 2. So the first 4 observations will belong to group 1. Observation number 5 will go to group 2, and then observation number 6 up to 13 will go to group 13, group 1, and the rest, guys. So question, do we have the same partitioning? Kindly chat yes, please, or no?
Yes, sir.
Okay. The rest? Okay, pareho ba tayo ng partitioning? Okay, good. Now that happened, guys, because we set that seed. Yun ang purpose ng set that seed. Otherwise, kung hindi tayo nag-set ng seed, guys, then we will have different partitions. Okay, you'll have a different trained data and you'll have a different test data. Okay, so since we have the same trained data, the same partitioning, then we expect, guys, that our results will be the same. Okay, our model will be the same. Okay, so let's now create a data called trained data. So sino itong trained data na to? Si trained data is coming from my data. Pero it's a subset natin siya, di ba yung brackets na to? It's a subset where the ind, ano yung ind? Di ba ito yung data na ones and twos? So lahat daw ng 1, okay, ind is equal to 1. So take note, guys, dalawang equal to dito, ano? Sa subset, ganun ginagawa, dalawang equal to. Ind is equal to 1, and that's for the trained data, comma, di ba, ang subsetting rows and columns to, di ba? So all the rows, guys, that were ind is equal to 1, pupunta sa trained data, columns kasama lahat, no? So since wala tayong linagay dito na value, that means all the columns are included. Yung admit, GRE, GPA, and rank. Okay, so for the test data, ang kasama dyan yung lahat ng number 2 dun sa index. Okay, so let's run this. Run. Okay, so if you take a look at our objects here, meron na tayong train, okay, at saka test data. So si train, guys, 325 observations. Kasi 80%, di ba? 80% of 400 observations. That's around 320. No? Approximately 80% to. And then for the testing data, that's 20%. So hindi exacto yung pag-split niya, but that's okay. Right? So let's take a look, for example, at our train data. Let me just click the... okay, ito yung train data natin, guys. No? Take note, ano yung mga train data natin? Yung si observation 1, 2, 3, 4, wala si 5, di ba? Tingnan nyo. 5 is not here. Observation number 5 is not here because it went to the testing data. Okay, etc. No? So may mga gaps dito, yung 13, tapos ang susunod 15 na. So ibig sabihin si observation number 14, napunta siya dun kay testing data. And let's check guys si testing data. Click natin to, test data. Click natin yung icon dito. Spreadsheet. There you go. Diba? So observation number 5, 14, 16, etc. 75 entries, which is approximately 20% of the my data observations. Okay. Clear guys so far? Pakichat naman please kung clear tayo. Itong part ng ano natin, itong pag-partition ng data natin.
Clear, sir.
Yes? The question? Okay, thank you. Thank you guys. Sana 100% guys nagre-respond. Ha? Okay, then let's now go to logistic. Logistic regression na tayo. So ang gagawin natin dito guys, imo-model muna natin. Imo-model natin si train data natin. Gagawa hahanapin natin ng model. Tapos kung ano man yung model makuha natin doon, whatever model we derive out of the train data, we're going to run it for the test data and see if our model is okay. if it's still okay, if it can be relied upon. Okay. So what's the code, guys? What's the code? Unlike sa regular multiple regression, guys, where we just use LM, no? Dito, okay, sa ano guys, sa binary logistic, we're going to use the generalized linear model. So we use the GLM function. Okay, so just to have some insights about it, question mark tayo dito, question mark, GLM. Okay, so what's the GLM function all about? So it's coming from the stats package. So sa stats guys, kahit na hindi natin rinload siya, automatic available na rin siya even if we did not use library stats. No? Okay, so ito yung GLM, no? So you have your formula, then you have here some other parameters that we need to put in. Kung hindi tayo maglalagay ng parameters dito, may default yan. And then ano yung data natin? Weights, kung kailangan may ibibigay tayong weights, may subset, pwede rin. Okay, then start, okay, etc. So maraming ano dito, no? Maraming pwede natin ipasok. And then dito guys, yung type. May type tayo dito. Type, tapos may family din. Or method. Okay, let's take a look at family. No? So iba-iba yung families guys. Okay, let's click family. Yan. Ano yung mga family na pwede? Pwedeng binomial, pwedeng Gaussian, pwedeng gamma, inverse, Poisson. Okay, so these are the families of models that we can generate dito sa GLM na to. Okay? All right. So ang family natin na gagamitin guys is binomial. So GLM natin, let's create this object called my model using the generalized linear model. Ang dependent variable natin is admit, which is a factor, guys. Okay? Factor siya. So, pwede natin actually gamitin dito LM. Sige nga, ipakita lang natin. Okay, let's just run Control C. Dito, Control V. Okay. So, dito na lang natin i-run. Oops. Mali. Saan ba yan? Ba't nawala yung ano natin, equation? Okay, nawala yung equation. Okay, so let me just copy this here. Control C. Tapos mag-insert na lang ako guys dito ng ano. Alt Shift I. Control V. Yung alam natin guys, no? Let's just call it my mod. My mod na lang. And then LM siya, di ba? LM. And then tatanggalin natin tong family na to. Okay? Kasi hindi naman natin take note, admit is a factor, di ba? Admit is a factor. And then we're going to regress it on the 4 predictor variables, GRE, GPA, at saka si rank. Then the data that we're going to use is not my data, but the trained data. Okay? So tingnan natin guys, ano mangyayari dito. Okay. Ano sabi niya guys? So what does this tell us guys? Ano daw sabi? Kapag mag-linear model lang tayo guys, okay? Nag-error dito, no? It did not create the model. Okay, tingnan natin. Create pala niya, andito pa rin yung my mod. Pero let's see. No? I-summarize natin. Summary, my mod. Create niya, guys. Pero may ano tayo dito, may caveat tayo dito. Yan. Okay, what are we being told here? Factors are not allowed. Okay, kasi guys, yung ano natin, yung response variable natin, yung dependent variable natin, this is a categorical variable. Okay, so hindi siya nag-run, no? Hindi nag-run dito sa LM function. Okay, so we have, lagyan natin ng note to. Using LM for a categorical variable as your DV will not run. Okay, so hindi siya pwede. Kasi admit natin categorical variable yan. So we have to make use of the generalized linear model and define that the family should be binomial. So let's run this now. Ano run ko na ba? Okay, run natin. Okay. Take a look at this. May nag-chat ba? Okay, thank you. Okay, so, yung kinocall lang yung formula natin. It's a GLM. Ang formula natin, admit, regress on GRE, GPA, and rank, family binomial. Data, we're using the trained data, guys. Take note, trained data to. Hindi to yung my data. Okay, admit guys is a factor. So sabi natin binomial. So admit dalawa lang, no? 0 or 1, kaya binomial siya. Okay, then we have here the deviance, parang residuals to ng yung ordinary na OLS natin. And then here we have our factor, our outputs, no? GRE, GPA, rank 2, 3, 4. If you recall guys, ba't naging rank 2, 3, 4 to? Anyone? Bakit siya naging rank 2, 3, 4? Guys, alala niyo yan? Okay, thank you, Masahiko. Very good. Very good. That's correct, no? Since rank is a categorical variable, so automatically ang ginawa ni R, hinanap niya yung the value that will come alphabetically, mauuna si rank 1. No? So automatically ginawa niyang benchmark si rank 1, ginawa niyang baseline. So there will now be 3 dummy variables. Hindi natin pwedeng isama si rank 1 as a dummy variable kasi we're going to fall into what we call the dummy variable trap. No? Magkakaroon tayo ng errors pag sinama natin si rank 1 also as a categorical variable, as a dummy variable. It can be done, guys, by the way, guys. Pwede natin isama si rank 1 as a categorical variable, as a dummy variable. Kaso, dapat tatanggalin to. You should remove the intercept. Okay? Dapat tatanggalin yung intercept. Okay, sige, pakita ko lang sandali yun, ha? Kasi baka sabihin nyo na ano na hindi na pa pwedeng gamitin si rank 1. Pwede pa rin. Pero let me dito ko na lang i-run guys. Above lang. So let me just check Kasi control C dito. Okay. So lagyan ko na lang dito ng that. Let me just check. I'm not sure about this. I haven't checked this guys if it will work. So the negative one there indicates that yung dot dito, di ba, ibig sabihin niya then use all the independent variables as regressors. And then -1 here means that do not compute for the intercept. Let me check guys. Gawin ko tong may M na lang, no? M1. So that hindi siya makaka-apekto sa ano natin. Summary M1. Okay. So let me run this. Okay, let me see guys. Alright, tingnan nyo. Diba? Okay. Rinan niya, no? Kaso hindi na siya naglagay ng intercept. Okay? No intercept, pero kasama yung mga rank 1, rank 2, rank 3, rank 4, rank 5. And they're all significant, diba? They're all significant. Okay? So, but let's just do the usual na sinasama yung intercept. Okay, you may wish guys to make a footnote of that. Control X, dito ko lang ilalagay sa ilalim. No? Control D. If we include rank 1 as a dummy variable, exclude the intercept. Okay? Exclude the intercept, guys. So, tinanggal natin intercept. Tapos, ito na yun, no? -1. That will exclude the intercept. Let me just put there. Okay. So, let's go back here, guys. Okay. Kung titignan natin yung model natin, so we're using GRE, GPA, and rank binomial. Okay. So we notice, guys, that GRE is not significant. Okay, so hindi significant predictor ng admission to the university, this university, yung GRE. No? And then GPA is significant, so importante. Rank 2, okay, remember when we interpret this should be interpreted in relation to your benchmark variable, your benchmark, which is rank 1. So rank 1 is not significant, but rank 3 and rank 4 are significant. So hindi natin, guys, we cannot remove rank as a predictor. Kasi even if, although rank 2 is not significant, the others are significant, rank 3 and rank 4. Okay? So GRE is not significant. Therefore, we cannot just say that this is the final model natin. So isa lang naman ang pwede natin matanggal, no? Just one. We can only remove GRE. So this will be our living variable. As I said, guys, we cannot delete, we cannot remove rank as a predictor. Okay, so let's go down here. Okay, so what are the significant variables? Sagutin natin to. GPA and rank. Diba? Yung dalawa lang, no? Yung significant natin. Okay, GRE is insignificant. Okay, so what we're going to do is we're going to create another model. Okay, let's call it again my model. And then GLM na naman, kaso tinanggal na natin dito guys yung ano. Tinanggal na natin yung GRE. Okay, GPA and rank forms part of our model, but not GRE. So data is trained by family binomial. So let's run this again. Okay, so let's see now guys. Okay, so only rank 2 is not significant. But we said that we cannot remove this. No? So ibig sabihin, hindi natin ma-distinguish si rank 2 at saka rank 1. Okay, that's what this means because we cannot interpret now rank 2 with reference to rank 1. Okay, because it's significant, insignificant. But we can interpret rank 3 and rank 4. Okay, so ano ibig sabihin nito? Quickly, what does 1.3735 mean? Okay, it means that by a one point increase in GPA, okay, means, okay, so yung 1.3735 na yan, i-explain ko in a while, no? This is what we call the log odds ratio. Okay, log odds. Sulat ko lang dito, no? Just for it's called the log odds. Okay, explain ko kung bakit log odds siya. Okay, so we have to be careful in interpreting this, yung 1.3735 na yan. Strictly speaking, ang ibig sabihin nito, for every 1 point increase in GPA, there's a 1.3735 let's say okay, log odds, no, increase in being accepted. Okay, so pag tumataas yung GPA, the log odds, okay, for being admitted, okay, increases by 1.3735. Si ano naman, si rank 3, okay, while you're going further and further away from rank 1, kasi di ba si rank 3 mas mababa kayo sa rank 1. So si rank 3 daw, okay, there's a 1.16 less chance, log odds chance of being accepted into the program, into the university, okay, in comparison to rank 1. Okay, so si rank 3 less yung log odds na chance of being accepted. Lalo na si rank 4, 1.56 for every si mga rank 4 daw guys, they have 1.5642 less log odds chance of being accepted to the university. Okay, so this will be our final model, and let's interpret this further. Okay, so before we do that, okay, magkaroon muna tayo ng prediction, no? Let's do some prediction. Let's create an object called P1, okay, and we're predicting using the my model, predict yung my model natin, okay, using the trained data, and type is equal to response. Okay, explain ko mamaya yung type is equal to response. So let's run this. Okay, so okay, let's print P1. Control Enter. So ano si P1 guys? I-view nga natin para mas view P1 para mas kita natin. Okay, di ba nag-create tayo ng object? Okay, we created an object called P1 and we're using the predict function. Predict using yung my model, yung binomial regression natin for the trained data. Tapos yung type, yung response. Okay, so it generates this object. Okay, 0.213, 0.314. So these are the probabilities. No? Ito yung mga probabilities na matatanggap si applicant number 1, applicant number 2, applicant number 3. So this gives us the probabilities of being accepted. So kapag greater than 0.5 yan, then tanggap siya. Pag less than 0.5, then hindi siya natanggap. So itong 0.213, hindi natanggap yan, no? 0.314, according to our model, no? Hindi siya natanggap, rejected. This was accepted, rejected, 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 rejected. So all those values, all those probabilities that are less than 0.5, okay, were rejected. Okay, ito yung mga probabilities natin. Okay, so punta tayo dito, no? Okay, so let's compare, guys. Let's compare yung P1 natin at saka yung trained data natin, di ba? Okay, let's see. P1 and the trained data. Yung first 6, ano nila? Okay, tingnan natin guys, no? Okay, so ito guys, the first prediction, yung P1 natin yung predicted value, 0.21. So ibig sabihin, according to the model, this should be rejected. Ano yung actual? Actual, rejected siya, di ba? So correct, no? Tama tong unang prediction. Second prediction, 0.31486. So according to our model, ang prediction natin, this will be not accepted, not admitted. Pero yung actual, admitted siya. Okay? So ibig sabihin mali itong prediction na to. Number 3, 0.72 greater than 0.5, accepted to, no? Admitted. Number 3, admitted. Okay, tama. So itong pang-apat, 0.1446, not admitted to. Yung pang-apat dito, admitted. So mali na naman. So we will see that yung model natin, may mga tama, may mga mali. Kasi hindi naman talaga makakaano ng perfect na prediction yan. No? So si number 6, 0.30, rejected, accepted dito. Si number 7, 0.349, rejected dapat to, accepted dito. So you can see the discrepancy. No? Nakita natin na sa model natin, sa my model natin na binomial logistic regression, meron tayong correct predictions, meron ding wrong predictions. Okay. Now, let me go back to so explain ko guys, ano yung values na to? Ano yung model natin? Itong mga negative 4.2, 1.3, negative 0.5. So medyo different siya guys when we interpret it compared to your linear model. Sa linear model natin guys, kung LM to, kung multiple linear regression, straightforward yung model natin. Ilalagay lang natin negative 4.72 plus 1.3 GPA. Tapos pwede natin tanggalin tong rank. Okay? Yung iba sinasama din yung rank 2, no? Kahit hindi significant. So they still include that just to distinguish that from rank 1. And then rank 3, okay, significant siya. Negative 1.1645 times rank 3 plus negative 1.5642 times rank 4. Okay? So, okay tayo dito, no? That's our model. However, guys, yung ano natin, yung y natin. So, ang y natin, guys, y is equal to this one, and y is equal to the log odds ratio. Okay? So, sa multiple linear regression, hindi ganito yung y. Y is simply y, whatever your dependent variable is. So logistic regression, the y is equal to the log odds ratio. Now this is called log odds, no? Bakit? Odds, guys, is the probability of being accepted divided by the probability of not being accepted. So yung P na yan, P is the probability na ma-admit yung student. 1 minus P is the probability that the student will not be admitted. So the ratio of that, guys, is called odds ratio. P over 1 minus P. Probability of being admitted divided by the probability of not being admitted. That's called your logs ratio. That's why kung kinuha natin yung log niya, ln, ang tawag sa kanya, log odds ratio. Okay? I hope that's clear, guys, no? Kung bakit tinatawag siya na log odds ratio. Una yung odds ratio, it's just the ratio between your probability of being accepted divided by the probability of not being accepted. Okay? And then you get the log. So you have now your logs ratio. Pause muna ako, guys. Is this clear? Clear ba yung ibig sabihin ng logs ratio? Paki-chat nga, please.
Yes, sir.
Okay, thank you. Yung iba, guys, paki-chat naman, please. Okay, bubuksan ko lang yung Excel. Mag-Excel lang ako. Oops. Lumalabas yung sa FMDF na kanina, no? Magbubukas lang akong bago. File. Okay. File. Oops. File. New. Bukas lang akong bagong Excel file. And then let me explain to you. Okay. Let me explain to you the log odds ratio para clear sa atin. No? Kasi pag alam natin, guys, yung sa binomial, alam na rin natin sa multinomial. Kasi multinomial logistic regression, ganito din yung pag-interpret. Okay, so we're trying to shoot two birds with one stone here. So i-access ko lang yung digital pen ko. Okay, time check. Okay, so sana matapos natin at least yung binomial logistic. Okay. Kaya na-access ko na ba? All right. Review. Saan na yung ano ko? Wala. Sabihin hindi ko pa na-access. Ito na. Start inking. Okay? All right. Sige, sulat muna ako guys. No? So we said that our equation, si y is equal to yung log odds natin, no? Log or ln, log of the odds ratio. Probability of being admitted minus over 1 minus p. So ang tawag dito guys, odds ratio to. This is your odds ratio. Kaya nga ang tawag sa kanya, log odds ratio. Okay, and it's equal to beta null plus beta 1 times your, so ang mga pumasok lang sa atin, GPA, no? Okay, plus beta 2 times, okay, sige, huwag na natin ipasok si rank 2. Okay, sige, rank 2 na lang, pasok na natin. Plus beta 3 times rank 3 plus beta 4 times rank 4. Okay, can somebody please dictate ano yung intercept natin, ano yung value, please? Para mas mabilis tayo. Can somebody please dictate what's the value of our intercept? Please, guys.
Negative 4.7270, sir.
Okay, kahit 2 decimal places na lang. Oh. Thank you. Negative 4.72 plus, what's our B1?
1.37.
1.37 times GPA, di ba? Plus, what's our rank 2? I think that's a negative.
Negative 0.57.
0.57 times rank 2. Although yung iba guys, sabi nga natin, hindi isasama tong rank 2 kasi nga insignificant siya. But for our purposes, sige, isama na lang natin. No? And for rank 3, it will be what? Negative 1.16,
sir.
1.16, rank 3, and then rank 3 plus negative 1.57 ba?
56, sir.
Okay, thank you. Thank you. Thank you so much, okay? So that's our equation, guys. That's our equation. And everything here, everything there is equal to the log of P over 1 minus P. Yun ang equation natin, no? That's our equation. Okay, sige, let's compute kung ano yung value na to for sample number 1. Okay, so let me walk you through what's happening in the values here. Okay, so let me just copy. Okay, kinopy ko lang tong ano So ito yon actually, no? Ito. Control C. Isama na natin si rank 2, no? What's rank 2? Ano niya? Intercept, anong slope niya? I-copy ko na lang to. Control C, no? Okay, since we're including it, some might as well include it here. Control V times your rank 2. All right. So this is, guys, this is the equation. This is the log odds ratio. So let's compute it first. How do we compute it? Well, we go to each sample, no? So tingnan natin. Okay, let's take a look at asan na to? Ito, guys. Si sample number 1. Yan. So si sample number 1, ang GRE niya 380, ang GPA 3.61, ang rank niya 3. So how are we going to apply it here? Okay. Sige. Para na control C para ma-maintain natin yung initial equation natin. Okay. So GPA ni number 1, ni sample number 1 is 3.61. So I'm going to copy this 3.61, control C, and then replace my GPA here by 3.61. Sa-substitute lang natin. So si rank, nauna si rank 3 pala. No? Okay, si rank 3 siya, di ba? Rank 3. So dapat, since this is rank 3, then we will replace this by 1. Okay, kasi rank 3 siya, so tama ito. Papasok tong slope na to. But for rank 2, isi-zero out natin to kasi hindi naman siya rank 2. Si rank number 4, isi-zero out din natin siya kasi hindi siya rank 4. Okay, there you are, guys. So that's now the value of the logs ratio for student number 1. If we press enter, okay. So ano to? Negative 0.993165. Okay, so yung negative 933.165 na yan, that is now our logs ratio. So let me go back to this. Copy ko lang to. Control C. Okay. And then let me go back to my Excel. Ito yan. Okay, so okay. So that's your 933.165, no? Ito 'yon. Okay. Now, unfortunately, ang hirap i-interpret ng ng log of P over 1 minus P is equal to negative 0.933.165. What does that mean, di ba? Pag sinabi natin ang log odds ratio ni student number 1 is negative 0.933.165. What exactly do we mean by that? Good thing na lang, guys, pwede nating i-convert, no? Okay, so i-convert natin yung log odds ratio na yan. So how do we convert that? Okay, again, guys. Okay, asan yung review ko? Okay, how do we convert? Okay. So, di ba guys, ito yung y natin, no? This is our y. So, y is equal to itong negative 0.933.165. Okay. But we know, guys, that is equal to the log of P over 1 minus P. Okay. So, what we can do is we can convert this value of y, we can convert that into the probability. Yun ang kagandahan, guys, no? Kasi pwede natin isolve si P. Remember that P is the probability of being admitted. Okay, so let's do that. So how do we convert? So sulat ko lang yung equation, no? So using just simple arithmetic, no? So we know that y is equal to log of P over 1 minus P. Okay, so actually that's ln, no? Ln natural logarithm of P over 1 minus P. Okay, so paano natin matatanggal si ln? Ang gagawin natin, i-raise natin to e, no? Raise it, exponentiate it. So we will have now, say y to, no? Y is equal to that one. So we now have e to the y is equal to e to the ln of P over 1 minus P. Okay? Bakit nasulat ko? P over 1 minus P. Okay, yan. And then what now happens, guys? Okay, inverse functions to yung e at saka ln. So this will cancel out. Magka-cancel out to. Yan. So we now have e to the y is equal to P over 1 minus P. Okay, then so let's transpose this. You have e to the y times 1 minus P is equal to P. Diba? Transpose, and then we can distribute e to the y minus e to the y times P is equal to P. Okay, so simple arithmetic lang yan, guys, ha? Simple algebra. Then we can put e to the y now is equal to transpose this to the other side. P plus e to the y times p. Therefore, we have e to the y is equal to p times 1 plus e to the y. Okay, therefore, we can now isolate p so that p is equal to e to the y over 1 plus e to the y. There you go, guys. Okay? Our probability is equal to e to the y divided by 1 plus e to the y. So can we compute for the probabilities? Yes, guys, because for each observation, alam naman natin yung values ng GPA, kung rank 2 siya, rank 3. So mako-compute natin yung itong y. Okay? So that's our y, no? So just perform this. E to the negative 0.933 over 1 plus e to the negative, etc. So let's do that here, guys. Okay? So ang p natin will be, okay, so that's exp. So that's e, no? Sa R, ginagamit natin yung exp. Okay? Divided by exp to the 1 plus, 1 plus, mali, no? So this should be parenthesis 1 plus Control V. Oops, mali. Okay, highlight ko. Control V. Oops. Bakit ganun? Ano nga? Copy ko ito. And then close natin. Yan. So we have this numerator e to the y divided by 1 plus quantity 1 plus e to the y. Okay? So let's now run this. What do you get, guys, if you run that? Paki-chat nga, please. If you run this, what do you get? Okay, I'm getting, how about you guys? Yes, how much? What's the value? What's the value that you're getting for this, guys? Ano yung probability of being admitted? Okay, so sige, pause muna tayo. Pause muna ako kasi I'm sure you're still doing the formula. I think I didn't give you time to run this. Okay, let's see, guys. 0.282283. 0.65, masahiko. Mukhang check your, mukhang mali itong 0.65. It should be around 0.2822, no? Mga ganun. Kindly check, masahiko your work and then paki-chat ulit kung yeah, be careful of the sign, no? Okay, so you should be getting, control enter natin. Okay, I'm getting 282283. Okay. So how does that compare now with yung value natin kanina? Di ba kanina, rinan natin, asan yung predict natin? Ano yung P1 natin? So let's see P1. Ito. P1. Wait. 1, 3, handali parang iba. Asa rin yung head at saka, okay, this one. Compare nga ulit natin to. Two, 1, 3, 4. Okay, bakit 2, 1, 3, 4? Mukhang malayo yata. we should have gotten, baka may mali ako sa ano. Let me check, guys. 2134, pero kanina tayo 28223. Bakit? Saan tayo nagkamali? Ano ba yung first ano natin? Ay, mali. Okay. I think I picked up. Saan ako nagkamali, guys? Train data to, no? Sorry. Train data to. Mali. Mali, guys. Dapat test data yung tinitingnan natin kasi ang rinan natin, guys, yung test data. I'm sorry, guys. This should not have been our, dapat yung ano natin, okay, dito na lang, no? Train data. Okay, so ang GPA natin, 3.6, wait. Test pala, test. Sorry, test data, no? GPA is 2.93 at saka rank 4 siya. Control C. Apologies, guys. Okay, so I have to copy this again. Okay, copy ko muna to, no? So this is our equation. Control C. Okay, the reason why, guys, mali yung ano natin, mali yung output is that we replaced it with the train data. Itong 3.61. Eh, ang ginagamit natin test data, no? So GPA should be 2.93. Okay, so let's replace this by 2.93. Control V. Mali. Copy ko muna to. Control C yan. Control V. 2.93 and then rank niya is rank 4. And then, saan ba ako? Train data. Oh, tama pala. Train data. 3.61 at saka 3. Yeah, this is correct. Sorry guys, medyo na-confuse ako dun sa train at saka test. My apologies. Let me backtrack, guys. Let me backtrack. Okay, sige. So this should be train data. So 3.61 yung ano niya, yung control C. Pero ito yung kanina, di ba? And then rank 3 siya, so dapat 1 to. Kasama siya sa computation. This should be times 0. Wala to. Oops. And then this should be 0. Okay, enter. Okay. But where did I get yung negative 0.9 kanina? Eh, bakit mali tayo dito sa ano? Yung computation natin kanina, no? Negative 4.27, then we replace it by yung GPA by 3.61. And then this is rank, ano to? Rank 3, kabaliktad kasi ko. So negative 1.645 times 1 plus this one times 0 minus this one times 0. So what I'm getting here is, hindi pala kompleto to. Dali. Guys, what did you get here? Dito sa unang-una natin. Okay. Ayusin ko muna to, ha. So let me first copy this. Control C. Okay. Okay. Lagay ko dyan. Para hindi nakakalito. So, next, tapos ilalagay ko siya dito after rank 2. Okay, apologies guys. Okay, so let me rearrange our model para hindi ako nalilito. Okay. So this model was generated using the training data set, no? We use the train data set in order to compute for the model natin. Okay, what I want to do now is I want to compare, no? Ito nakuha natin na probability na to na 213. Okay, dapat dapat guys, dapat we should get the same here. Okay? So yung first observation natin is ang GPA niya 3.61. So I'm going to copy this, Control C, and then replace this by Control V. Delete. And then rank 2. Okay, let me replace this with 0. Hindi siya papasok. Rank 3. 1 siya. Kasi rank 3 siya dito. Ano? So kasama siya. And then rank 4 is 0. There. Okay, so if we run that, compute on negative 933. So bakit? Dali, Let me see. Tama yung equation natin. So e to the y is equal to b. Okay, tama. This is the equation. E to the y over 1 plus e to the y. Now, I don't know why I'm getting a different answer. And so it should be close to 213536. So E EXP ba? Yeah. Exponential din to eh. Pareho din. Control C, Control V. And then i-divide natin, open parenthesis. Okay. 1 plus E. That amount. Open, close, close. Okay. But tama guys, no? E to the y divided by 1 plus e to the y. Okay, control enter. 28223. Bakit 28223? Why am I getting 28223? Dapat ano siya eh? Dapat around 2134. Okay, how many among you guys got 2134? Anyone, guys? Why am I getting 28, 22? Dapat train data. Yung may model natin. Yeah, that's correct. My model. We should be getting, guys, we should be getting 2134. Okay, I wonder why, guys. Okay, sige. Let me recheck this, guys, no? Rank 3. Hindi ko na sinama yung rank 2 dito. It should still be okay. Guys, can you see where I made a mistake? Karahan ko lang to sa isang section eh. Makuha naman namin yung value. Bakit ano? Why am I getting 0.2822? And here the probability is 0.2134. It should be close, no? So dapat kung may discrepancy lang, 5th or 6th na decimal place. 93165. Okay, guys, may I have your feedback? Ano nakuha nyo, guys? Yung nag-grant sa inyo, ano nakuha nyo? Hello? Oh, ito din, 28223. Bakit iba? P1, predict my model using the trained data. Type is equal to response. Okay, let's see. First value in my P1. Oh, bakit sa inyo yung P1 2822? Okay, thank you, Masahiko. So, sa P1 ni Masahiko, 2822. How about you guys? Ano yung value nyo sa P1? Hello, guys? Paki-check nga kung ano yung value nyo sa P1. Is it 2822? It should be 2822 kasi based on our computation, why am I getting 213? So something's wrong with this. Hello guys, hello. Feedback naman oh. I want to know what happened sa inyo, please. Did you run your data? Yes?
Sir, pareho rin po ako nung answer kay Masahiko.
Okay. Okay, at least tama kayo, no? 2822. So dapat 2822 guys yung unang ano. Pero kay Laika 213. Bakit? Okay. I'm wondering why. Dapat it should be kasi kinumpute natin no? Based on the GPA and the rank of the individual. Okay, ito yung train data set natin. Ito 3.61 no? Okay, we should replace the GPA by 3.61 and then replace yung rank 3 ng 1, yung rank 2 and 4 0 dapat yan. Let me see the other 2822. Okay, 2822 si Matthew, si Aubrey 2822. Okay. So Laika mukhang may mali tayo no? Okay, kasi rinan ko na to. Karawan ko lang nito kahapon and I was getting 2822 dito sa P1. Okay, so why am I getting this one? 2134. Okay, so sige guys let me just explore this so that we don't waste time. At least for some of you, or hopefully for most of you, you got the answer. And what's important here guys is we know how to compute for the probability. And we know that the equation, yung output dito guys sa isang binomial and for multinomial is the log odds ratio. Okay? So we are not able to interpret that in the same manner as we do for a multiple linear regression, yung simple, no? Okay, so let's continue. Ito nga ito sinulat ko Okay? Ito nga yung yung y value, yung log odds ratio. Tapos kinompute natin to 1 plus tama Tama. But I'm getting here 28223 which is correct, no? Pero sabi ko dito, it's a little bit different from the output. Okay? Just to rounding off error. So konti lang difference. Okay, sige. Anyway. All right. So what we're going to do now, guys, is we're going to convert yung P1 natin. No? Kasi iba yung P1 ko Iba yung P1 ko. Bakit? Okay, so i-check ko na lang ito mamaya. No? So we're going to create an object called pred1. Yung P1 papalitan natin. Lahat ng P1 na greater than 0.5, gawin nating 1 yon. Otherwise, 0. So we use the if-else, no? If-else function. So we're creating an object called pred1 where it's coming from P1. No? So lahat ng P1 na greater than 0.5, papalitan ng 1. The rest will be 0. Okay, so let's run this. Let's run this too. Control Enter. Okay, so view na lang natin. View si pred1 para mas mabilis. Okay, so this is pred1. Yeah, yan na guys. No? That's related to P1. So this is less than 0.5. So gagawin niyang 0, 0, 1, 0, 0, 0, 0, 0, yung 10, 1. So yun ang ginawa niya dito. 0, 0, 1, 0, 0 hanggang yung 10, 1, etc. So we just converted our P1 into numbers of 0 and 1, into factors of 0 and 1. Why? Why are we doing that? Why did we do that? Because we're going to construct our confusion matrix. No? So ano si confusion matrix? So it's a table. Table siya. Okay, we're going to call it tab 1. Okay, tab 1 siya. And then we're going to give this, ito yung y-axis natin, ito yung x-axis natin, okay? So let's give it a name, predicted, and it's equal to pred1. Okay, and then ito tabular niya, actual naman sa x-axis, and this is from your trained data, and just your variable admit. No? So isa side by side natin yung pred1 natin at saka yung admit na galing sa train, yung admit variable natin. Okay, so let's run this too and let's see what happens. Okay, so ito na yung ano natin. Okay, did you get this, guys? Pareho ba tayo ng ano? Ng actual at saka ng predicted, 205, 827. Kindly chat please if you get the same answer.
Yes, sir.
Okay, good. The rest, guys, may nag-chat na. Okay, good. Okay. So nagkaiba tayo dun sa probability. I don't know what happened, pero at least same tayo sa confusion matrix. So what does the confusion matrix tell us? Si confusion matrix, it tells us, ito yung 0, predict niya na 0, and then i-compare natin sa 0 ba talaga siya. So yung actual niya 0, predicted 0, ibig sabihin tamang prediction to. Okay? So sa predict na 0, okay, 285 yon, 285 yung tama. Okay, ito naman 1, predict na 1, 27 yung tama. Okay, kasi actually 1 siya. So itong diagonal, guys, these are all the correct predictions. Yung off diagonal, yung wala sa diagonal natin, these are your wrong predictions. So predict na dito na 0 pero actually 1 siya. So mali ito, 75 instances. How about this one? Predict ng model natin na 1, okay, pero actually 0 siya. Okay? Predict na ma-admit dito pero actually hindi siya na-admit. So 18 yung wrong, 75 yung wrong dito. Okay? So let's look at the percentage ng correct predictions. So yung percentage ng correct predictions will be simply the sum of the diagonal of tab 1. This is tab 1, guys, yung table natin. So kunin natin diagonal, i-add yan, okay, divided by sum up lahat ng tab 1 natin. So that will give us the proportion or the percentage of the correct prediction. Diba? Control Enter. Okay, so 71%, 71.4% correct. Therefore, yung 1 minus that will be the wrong predictions. Okay, sama natin. Okay, 71% correct prediction, 28% or 29% wrong prediction. Okay, so that's how our model performed. So, predict natin si 0 or 1, guys, based on our binomial logistic regression. And it turned out that our model was able to predict 71.3% correctly, and then wrong 28.6%. Okay. Clear yun, guys? To clear? Pakichat nga please kung clear. Kung clear tong confusion matrix natin. Okay.
Clear, sir.
Okay, good. Yung iba, guys. Okay. Oh, tatatlo pa lang, guys, yung nagre-respond. Clear ba, guys? Up to this point? Okay, thank you. Good. All right. Now, we go here. Okay, so ang gagawin naman natin dito, i-on natin, guys. I-check natin kay test data. No? Kasi minodel natin using trained data, and now we're going to test our model using test data. So test data is a data which has not been seen by our model. Okay. So maganda yon kasi tingnan natin kung mag-work out yung model natin dun sa isang data set na hindi pa niya nakikita. Not yet been seen. Okay? So very quickly, we can go here. Let's create again another object, P2, where we're predicting yung my model natin. Pero ang gagamitin natin, guys, si test data na. Ha? Test data, and then same type is equal to response. I-run natin to. So may P2 na tayo. No? Okay, we can look at P2, but I hindi ko na gagawin. No? So I'm creating an object called pred2. So ganun din siya. If else then, so lahat ng P2 na greater than 0.5, gawin niyang 1. Otherwise, gawin niyang 0. Okay? So yan, may pred2 na tayo. Okay, hindi ko na i-access guys ha. And then let's create, parang yung kanina, another tab. Okay, kung gusto nyo guys, split natin to. Okay. So here we're creating an object called tab. No? Ganun din, predicted from pred2, ito, and then actual, yung test, admit. Okay, so let's take a look at tab 2. Okay. Remember, 75 lang yung elements ni ano natin, ni test. So correctly predicted yung 48 plus 4. Okay? So dito siya maraming mali, no? Predict niya na hindi ma-admit, pero na-admit in 21. Okay? Dito sa predicted niya na ma-admit pero hindi na-admit, 2 lang yung error. No? Dito siya malaking nagkamali sa 21 na to. And let's once again compute for the, okay, pagsama-sama natin ito lahat. Okay. All right. So we can see here that, okay, 69%, 69.33% of our test data was predicted correctly. So hindi masyado malayo dun sa training data, which is good. Yung training data natin, 71.38 lang. Okay? Ito, first time niya na-meet, ginamit natin yung model natin dun sa nagawa natin from trained data and apply it to test data. The model correctly predicted 69.33% and ang wrong lang yung 30.7, which is not far from the model natin. Okay? And then lastly guys, ito, this is just a test kung okay ba yung model natin, no? So we're going to use the chi-square test. Okay, so don't have to understand this muna. Basta ang null hypothesis dito guys is that the model does not clearly predict yung admit na variable natin. So parang ano siya, parang goodness of fit na F-test, no? Pero dito, chi-square yung ginagamit kasi ano to, binary logistic. Okay, kapag ano siya, kapag multiple linear regression, if you recall, yung goodness of fit test on F-test yung ginagamit. Okay, so let's run this. Okay, so we have here a p-value that's practically 0. So ang answer dito, okay, we reject the null hypothesis that the model is not able to predict your admit variable. So we have strong statistical reason to believe that okay yung model natin. Okay, so statistically okay yung model natin, significant, no? Significant yung mga predictors natin. Okay, based on the overall goodness of fit. Okay, so time na pala, sorry ha. So that guys, that's your binomial logistic regression. Okay, so next meeting, i-compare lang to, mag-i-introduce lang ako ng machine learning next week, next meeting this Thursday. Ang gagamitin natin si decision tree. Tapos tingnan natin kung how does decision tree compare with yung ano natin, itong goodness of fit na atong binomial logistic regression natin. Okay? And then okay, may time pa tayo sa Thursday, magmo-multinomial na tayo. So kindly read yung multinomial natin. Okay, kindly read this. And then pakisubukan nyo ng subukan nyo ng pag sa Thursday guys, naka-open na tong file na to. Tapos na-load nyo na rin yung cardiotocographic data. Okay, so this is now multinomial logistic regression. Ganun din guys, ang difference lang sa binomial, okay, at saka multinomial, mas magandang ang usually ginagamit. Binomial. Okay, ang difference lang nila guys, si binomial, dalawa lang yung level ng factors. Si multinomial, marami. 3 or more. No? Okay, so with that guys, we end our discussion today. Thank you so much. I-pause ko muna stop ko na muna yung record.